Now let's solve the solution to exercise 10. We are asked to evaluate the direction cosine of three vectors r1, r2, and r3. So let's begin with r1. r1 is 2i minus 5j plus k. 2i minus 5j plus k. And we are asked to evaluate the direction cosine. Since this is a three-dimensional vector, okay, is a three-dimensional vector, therefore we know that we will have three direction cosines. We will have cos alpha, we will have cos beta, and we will have cos gamma. Cos alpha, which is L, cos beta, which is N, M, cos gamma, which is N. Alpha is equals to X divided by the modulus of R1. Gamma is Y divided by the modulus of R1. And beta is Y rather, and gamma is Z divided by the modulus of R1. So since we are dealing with R1, we can call this alpha 1, beta 1, gamma 1. Now let's evaluate the modulus of R1. The modulus of R1 is equals to the square root of 2 squared plus minus 5 squared plus 1 squared. And this will be equal to the square root of 4 plus 25 plus 1. And this will give us root 30. Now we can evaluate L, which is cos alpha 1, to be x divided by modulus of R. The x in this value is 2. Okay, that's 2 divided by modulus 30 or root 30. And y, which is minus 5, that will give us minus 5 divided by root 30. And similarly z, okay, which is equals to 1 divided by modulus R1, which is divided by root 30. Now we can see how simple it is to evaluate direction cosine. Let's move on to the next question, which is R2. Question 2. We are asked to evaluate the direction cosine of minus 5i minus 8j. Minus 5i minus 8j, and this is a two-dimensional vector. And since it's a two-dimensional vector, we are going to evolve on the x-axis cos alpha 1 and on the y-axis cos beta 2. We can call this L2, we can call this M2, and we can, okay, that will be all. We know that in a two-dimensional vector, we are going to have x divided by modulus of R and also y divided by the modulus of R. So since we are considering R2, the direction cosine on the x-axis will be x divided by the modulus of R2. The direction cosine on the y-axis will be y divided by the modulus of R2. Let's evaluate the modulus of R2, which is equals to the square root of minus 5 squared plus minus 8 squared. And resolving this, we will have 25 plus 64, which is equals to root 89. And therefore, our x, which is minus 5, so we'll have this to be minus 5 divided by root 89. Our y, which is minus 8. Okay, so you have this to give us minus 8 divided by root 89. Of course, if you want to evaluate, confirm, we know that L1 squared plus M1 squared plus N1 squared is equals to 1. Similarly, L2 squared plus M2 squared is equals to 1. And let's solve for the last question, which is the direction cosine for 4i plus 3j plus 2k. That's question 3. Direction cosine for 4i plus 3j plus 2k. This, I believe, you are getting correctly, or you got correctly after you solved. Now, since this is a three-dimensional vector, we are going to have three direction cosine cos, since we are considering R3, so we have cos alpha 3, cos beta 3, and also cos gamma 3. This will be L3, M3, and N3. X divided by the modulus of R3, Y divided by the modulus of R3, and Z divided by the modulus of R3. Let's evaluate the modulus of R3, and that will give us the square root of 4 squared plus 3 squared plus 2 squared, and that will give us 16 plus 9 plus 4, which is equals to root 29. Now L3, which is the direction cosine on the x-axis, will be equals to 4 divided by root 29. 4 is equals to x, 3 is equals to y, and 2 is equals to z. Similarly, the direction cosine on the y-axis, which is cos beta 3, will be y, that's 3 divided by the modulus of R3, root 29. And the direction cosine on the z-axis will be 2 divided by root 29. Now let's have a special question. Let's say we are asked to evaluate the direction cosine of question 4. We call this R4, which is equals to R1 plus R3. Okay, this is a special. You can pause the question video right away. R4 is equals to R1 plus R3. So pause the video and give it a try. We are asked to evaluate the direction cosine of R4, which is R1 plus R3. Alright, let's solve it together. The first thing we will do is to evaluate what is R4. So we know that R4 is equals to R1 plus R3. R1 is equals to 2i minus 5j plus k. Just as we have here, 2i minus 5j plus k, and R3 is 4i plus 3j plus 2k. 4i plus 3j plus 2k. So we simplify this. So simplifying this, we have, let's open the brackets first, and we'll have 4i plus 3j plus 2k. And simplifying further, collecting like terms, on the I component, this will give us 6i. On the j component, this will give us minus 2j. And on the k component, we will have 3k. So we have R4. Now we are asked to evaluate the direction cosine on R4. R4 is a three-dimensional vector. X is equals to 6, y is equals to minus 2, and z is equals to 3. Now, since it's a three-dimensional vector, we are going to have cos alpha 4, cos beta 4, and also cos gamma 4. Cos alpha 4 is equals to L4, cos beta 4 is equals to M4, and similarly, cos gamma 4 is equals to N subscript 4. So let's evaluate the modulus of R4. Modulus of R4 is equals to 6 squared plus minus 2 squared plus 3 squared. And this will give us 36 plus 4 plus 9. And this will give us root 49, which is equals to 7. Let's begin with the modulus, direction cosine on the x-axis, cos R4. Cos R4 is equals to x divided by modulus of R4, and that will give us 6 divided by 7. Similarly, we will have this to give us y divided by modulus of R4, which is minus 2 divided by 7. And finally, cos gamma 4, which is z divided by modulus of alpha. Z is 3, modulus of alpha is 7. 3 divided by 7. Now we can see how we have combined direction cosine with addition and subtraction of vector. It can also be combined with let's say scalar multiplication. We can have questions like we should evaluate the direction cosine of R5 to be equals to 2i, 2R1 plus 3R3 minus R4. So we can have a question like this. Okay, you can give this a trial to challenge yourself. But the whole deal is to understand the direction cosine formula for 2-dimension and also for 3-dimensional vectors. For 2-dimension, we have cos alpha and cos beta. For 3-dimensional vector, we have cos alpha, cos beta, and cos gamma with their respective answers.